Hey guys, if you like discovering new specialists who help you change the way you look at the universe and your place in it, and thus your whole life, you're going to love today's show. Welcome to Two Seals and a Walrus, the only podcast on the web that has two United States Navy SEALs as co-hosts. I'm your co-host, Sean Webb, and to my right, we have United States Navy SEAL Ben Johnson, medic and sniper. And to his right, we have Doug Moulton, United States Navy SEAL, just a sniper. No medic.
No, that's it.
Although you've probably had some pretty basic medical treatment and medical training for the field. Is that correct?
Yeah, I know how to not let someone die sometimes.
Okay.
Does that count?
Well, that is going to be
fine.
pertinent for our discussion today because on the line, we have Dr. Neil Theise, who's a professor of Department of Pathology, co-director of gastrointestinal and liver pathology, and to his credit, has a number of accolades. He's an MD, but he's an MD with a pretty solid pedigree. Like, the stuff that he's worked on helped President Bush solve the problem that we had back in the headlines of whether or not we were going to use embryonic stem cells for research. He figured out how to do stem cells without having to pull them from babies or embryos. He also has helped identify potentially our 80th organ in our body, which is kind of a connective tissue. You've got like some amazing props that in science that under your research tutelage, and you just like on the front page of the newspaper today, you were saying in the New York Times that there's some stuff that you did back in 2000 that is now just getting some headlines. Tell us about that.
Well, that's the stem cell stuff. So my group, there were a few groups in 1999 and 2000 that started to look at how back up even more. Up until the late 90s, people really thought that the only organs in the body that likely had stem cells were your skin, your GI tract, and your bone marrow,
right,
producing all the cells of your blood. That's sort of where things sat for a while. My field is liver disease. Liver pathology is my clinical specialty. So I look at liver biopsies all day long, which for me is fun. I suppose kind of the same focus and concentration looking through a set of lenses as a sniper might experience.
I was waiting.
It's a contemplative sort of practice, you know. My team sort of was the one that confirmed that livers had their own stem cells, and human livers in particular. It wasn't just in animal experiments.
Okay.
But then to explain some of the data that had been produced over the prior few decades in animals, the human thing we were identifying where the stem cells hang in the liver didn't explain all that data. So we and others, for a variety of reasons, started looking at cells from the bone marrow. And it turned out that if you do a bone marrow transplant in mice, you can find the cells from the bone marrow, repopulate the new cells, replacing the bone marrow, repopulating the cells in the blood, but then winding up also as cells in the liver, in the brain, in the muscle. And so that was happening, like I said, 1999 to 2000.
Right.
And we were the first group to show that it happened in humans because we looked at men who had received female liver transplants and women who had received male bone marrow transplants and had liver biopsies for one reason or another. And so the difference between male cells and female cells is male cells have a Y chromosome and female cells do not. And so if you find a Y chromosome from a woman who had a male bone marrow transplant and you find a Y chromosome in a liver cell, that cell had to come from the bone marrow. And we did these experiments, usually using, hundreds of thousands or millions of cells to do the transplant. So people who were sort of opposed to this idea, because it broke a lot of dogmas, cells from one organ shouldn't cross over to another organ. That was a very strict dogma for a century. They said what you needed was a single cell transplant, where you transplant one single bone marrow stem cell, not one type, but actually one single cell into the marrow of a recipient animal and see where that cell goes. And my colleague, Diane Krause at Yale, she and I had been working on this stuff, and we teamed up with Saul Sharkis, who was at Johns Hopkins back then. And he had a bunch of mice where he had accomplished this. It used to be very, very difficult to do a one-cell transplant. And when he was getting ready to look at how those cells populated the bone marrow, we said, hey, could we come down to Baltimore and quickly do some autopsies on your mice? And we did, and we took samples of all the tissues. And all the tissues had bone marrow derived cells. And so that showed that one single adult stem cell could do everything everything an embryonic stem cell could do.
Wow.
And so that's how we got caught up in the politics of the stem cell stuff. And the thing with George Bush, he was trying to sort of split the difference between the anti-abortion lobby, which basically had the moral argument up until that point.
Right.
But no scientific argument. And our work sort of provided them with the answer that, oh, you don't need to do embryonic stuff. You can, because adult cells can do everything.
Right.
And then the community split into sort of two factions. One was the adult stem cell folks like me, where we were like, you sort of have to examine everything in order to figure out what's going on here. It's too early to say what can do what. You need information from both. Mm. But the people who were rigidly trying to protect the embryonic stem cell research, their response wasn't that, hey, this is complicated. It was, no, they haven't proven adult cells can do everything, so we have to continue to do embryonic stem cell research, which is kind of a false argument too. There's right. False arguments on both sides. And the result is that funding and the ability to publish the adult stem cell stuff was sort of squelched by those people trying to protect embryonic stem cell research. Mm. Ultimately, the way this played out is that because of research from both directions, the guy in Korea, whose name's escaping me at the moment, but he won the Nobel Prize for this, figured out that looking at what happens in embryonic stem cells and looking what happens in adult stem cells, he figured out how you could take any cell type, put it in a dish, give it a bunch of signaling molecules, and turn it into a stem cell that could do anything.
Wow.
Those are called induced pluripotent stem cells. And I don't know, 6 or 7 years ago, that and cloning, those were the two things that got the Nobel Prize.
Right.
So, and that's where stem cell stuff has gone, which is awesome. The problem is that we still have very little in the way of stem cell derived therapies. And I think that's sort of a byproduct of the politics of everything that flared in the 20s. I'm hoping that this article in the Times signals the idea that, oh, maybe a generation has passed. It's almost 20 years. And so the scientific prejudices and the political and the financial prejudices might start to lift. And maybe in the next 10 years, we'll start to see some stem cell promise finally.
Gosh, that's amazing.
One of those things where enough angry people have to die off before progress can be made.
Yeah, that's the third time this quote has come up today in my life. But yeah, my version of it, and this is like my favorite quote for the 20th century: "Progress happens one funeral at a time."
Damn.
Yeah, it's really depressing, but there you go.
Yeah. Now you and I met. It's been over a year since I've seen you. And one of the things that really drew me to your work was...
Well, where was it? I'm so many places, I can't remember where I met. I recognize faces.
Yeah.
Remind me where it happened.
It was at Science and Non-Duality. And you were speaking there, and I was speaking there, and we'd found a time to just kind of hang out.
Yes.
Because I was familiar with your work, and you were just kind of sitting outside the lunch area there, and I came and sat down and introduced myself and said, hey, I really enjoy your work, and I actually stole a part of your video and stole a part of your science for my second book. Sorry about that, but
no, and I remember, no, that's fine, steal away. I mean, that's public domain. Otherwise, why would I be here? But no, I remember the conversation. I just can't picture where it happened. So I was like, was it in Berlin at the fascia meetings? Was it at Deepak's thing a year ago or 2 years ago? So it was at SAND. Okay. And
it was amazing because you were the person who helped me put together the connecting material. Really, we have a bent on having discussions of consciousness here on this podcast, excuse me. And your work was the work that drew the line between point A and point B in a very logical fashion to make sense of what all the woo-woo folks have been assuming for a long time, which consciousness may be the fundamental fabric of the universe. You were the person who actually put the science together, starting from looking through the microscope of, looking at liver pathology and looking at cells and doing their thing, and how cells and the emergent property of what they're doing really translates all the way up from the quantum foam to the macro design of the universe en masse. And the whole system works on the same basic fundamentals and draws us right to the conclusion where we go full circle. We start at consciousness and then we come full circle right on back around to consciousness, which, of course, has some amazing symbology in Zen of being, they have a big circle as one of their symbols. And so, I wanted to have a chance for you to come on and talk about that and talk about what started that whole process for you, and then maybe explain it in layman's terms, because you do much better job of it than I ever could, even though I try to do it well in my book and my second book, and people say I do an okay job, but I basically lend all the credit to you in that whole process. How did you get that start, and where did this finally come together for you? And explain what you discovered in your mind that helps make sense of our entire existence.
And start.
The funny thing is I can do that.
Which is why we're having you on.
Yeah. All right. So part of the reason I spoke about that stem cell stuff was it is the ground out of which all this other stuff sprang.
Right.
So a friend of mine who I'd known for years, completely independent of anything of this, I lived in London for a while, a fellow named Peter Ride. One of his jobs in his life has been on faculty at the University of Westminster, where he would work on curating science, art, interdisciplinary projects. And it has been an interest more in the UK and Europe than here in the States, but sort of globally, that interdisciplinary approaches to problem solving often wind up with more creative solutions. And so he was involved with people who were studying this. Meanwhile, he had a friend named Jane Prophet, who's this artist. She was very well known. Where she really sort of came to the world stage in the art world was she was interested in how people related to virtual creatures,
Right.
Avatars and stuff. And this was very early, so like in the late 90s, I think. And she created a world called Technosphere, and you could create a little creature and define some of its characteristics and send it off into Technosphere. And you couldn't, there were no visualizations at that point, but you would get little postcards by email from your creature telling you what they were up to. And, they were, I spent the day grazing. I ran away from a carnivore. I tried to mate, but I didn't get pregnant. I didn't outrun the carnivore and I died.
Right.
End of story. And so they programmed how these creatures would interact within Technosphere and send these little messages out. But when they got to the point where there were thousands of little creatures that people had sent into Technosphere, they started to do things that had not been programmed. And long story short is there was one point where the entire population became very stable. There were no deaths and there were no births. And they went in and they looked into the computer code to see what had happened. And all the creatures of Technosphere had lined up in a single line and were marching from one end of Technosphere to the other. And no one had planned that.
Oh my gosh.
The uprising.
Yeah. The more entertaining one, so to speak, is that there was population stability for a bit. And then the herbivores started to, their population was growing where the carnivores were kind of stable. And then suddenly there was a population collapse of the herbivores. And it turned out that the herbivores had started to form herds, which had also not been programmed. And the herd would eat themselves into a enclosed valley. and the carnivores lined up at the mouth of the exit of the valley. And when the herbivores had consumed all the stuff to eat in the valley and tried to leave, the carnivores just had a feast. And that had not been programmed either. So
herbivore by proxy.
Right. Yeah. So the artificial life community got wind of what was going on here, and they said, "You've got the technosphere is alive. This is artificial life." And Jane at first was like, no, it's artificial life. It's not really alive. And they invited her to artificial life conferences, and she presented, and it turned out like, no, the technosphere became alive. And in what sense was it alive? It had become a self-organizing system of interacting individuals that without any programming, in a bottom-up kind of way, because inadvertently they had fulfilled certain criteria in how they designed the place,
right?
Emergent properties, that's the word you used, emergent large-scale structures started developing that had not been planned or programmed, such as the long march and the herding and the mass extinction of the herbivores.
Which is going to happen everywhere, by the way.
Yeah, that's a whole other, yes, okay. Progress happens maybe 1 million funerals at a time. Okay.
Bacon always wins.
So in any case, that was what she was doing. And my friend Peter, he was like, you got to meet Jane sometime. And whenever I was in London, she was out of town. And whenever she was in New York, I was out of town. So he got a grant from the Wellcome Trust for us to meet each other in each other's cities 3 times. And all we had to do was record our conversations so other people could look at how an artist and a scientist might communicate. And I was telling her, this was, I think, in like 2000, 2001, in the middle of all this stem cell crazy. So I was explaining that to her as she was explaining Technosphere. And she said, she noticed that the way I was talking about how cells interact with each other and move around the body and organize to repair tissues like stem cells sounded like the way people describe the creatures in Technosphere, or the way ants form ant colonies. This idea that there are interactions between these individual agents, as they're often called, ants, cells, Technosphere creatures, and there are rules for those interactions, and somehow out of those interactions, new things arise that can't be predicted. And this is how I got introduced to complex systems theory, complexity theory.
Right.
And that's the stuff so that was the doorway. It went from the stem cell stuff and meeting Jane and finding our commonalities across, our very different practices. So that started, you can look at cells self-organizing themselves into bodies the way ants self-organize themselves into a colony. But that immediately implies something, and it took a couple of years to actually get this insight. So you see an ant colony from a distance, and it looks like this shape on the ground. It might be moving, it might be shifting, but it looks like a dark thing. Or if you look at a flock of birds in the sky, that's even a more vivid thing for people. Murmurations of starlings, they look like shapes in the sky. And if you don't realize they're birds right off the bat, at first you're like, what's that thing? And then you go in close enough, or what they are because you've been taught that, oh, those are starlings, those are birds. So when you go in close enough, the thing that looked like a thing now reveals itself to be a phenomenon arising from smaller things. It's not a thing at all.
Right.
But the moment we talked about the stem cell stuff, well, if you go into the body of the bird, or the body of the ant, or the body of my finger pointing up at the starlings in the sky, we're nothing but, at the microscopic level, we're just cells self-organizing.
Right.
So the body as a thing has no inherent existence either. The body as a thing disappears when you go down to the cellular level, and then the body is just a phenomenon arising from smaller things.
Right.
And in the case of humans, well, 90% of our cells are bacteria, and 10% are our human cells. If you got rid of all those bacteria, we would pretty much die within maybe as little as hours, certainly within days. Right. So we don't have a living body without the bacteria that are part of it. So our bodies are communities of self-organizing cells, some of which are human, most of which are not.
Right.
So we were writing about that and complexity theory and stem cell biology and, for a couple of years. But then you get to the question of, well, is the cell a fundamental thing? And it's not. When you go down to the molecular level, cells are just self-organizing molecules in water.
Right.
And one of the key things I'll throw in here is, because while we were talking, Sean, before you started recording, you mentioned something about how the machinery of things self-organizing.
Right.
And that's one of the issues with why it's hard for people to see this, or why our culture has been slow to perceive these kind of things, is that the dominant metaphor for biology, to some extent since Newtonian mechanics and Descartes, but really robustly since the Industrial Revolution, is that bodies are machines.
Right.
And bodies aren't machines.
No.
Machines always do exactly the same thing over and over and over and over again. Bodies do not. Living things do not. So what's the difference? Living things always have some degree of randomness in them, so that you can't make rigid predictions about this input becomes that output. And so, for example, the way it plays out with ants, that's a particularly vivid version. From a distance, you look at a food line of ants and you get an ant, it goes from the food source to the ant colony.
Right.
And it looks like everyone's following the line. But if everyone were following the line, when the food source ran out, where would the new food source be found? Someone's got to be out there doing that. Or if you put your foot in the middle of the food line, who are the ants that are going to find the way around the foot? The ones that are in the food line are busy with the food line. So if you lean down and look more closely, you see actually that there's always a few percentage of the ants aren't following the food line. And those divergent ants are the ones who are more likely to find a new food source, or to find a new route around your foot, etc.
The rule breakers.
The ants with ADD.
Right, except that this is, and this is something to be careful about, because we often get into, everyone wants to fancy themselves one of the divergent ants.
Right.
The thing is that, get this all the time. I do too. The thing is that every ant in the food line had been a divergent ant, and every divergent ant had once been in a food line. So the roles shift. It depends on circumstances. But this focused range of randomness in the system is really, to me, the most interesting and key point. If you have too much randomness, you can't get any self-organization. You just get total disorder. But if there's no randomness, then if the environment changes, there's no way for the system to find a new response.
Right.
So this low-level randomness is what's important. And that's why we're not machines.
Yeah, and does that bring into account the uncertainty principle?
Oh, yes. Well, let's come back to that. Remember to ask me.
Okay. I don't want to take you off track. I know there's a logical...
But is what I'm saying complicated?
No, it's not. And especially in the way that it rolls up and reverse cascades into larger structures with the same fundamental mechanism of slight randomness and self-organizing and emergent properties. And by the way, we're talking about the bird becoming the flock of birds. And an emergent property is a mathematical term, but basically it's the mathematical term that explains what happens when a bird becomes a flock of birds. You have a bunch of individual birds that then start to act as a body. But then the body itself self-down-regulates into the bird themselves. So the big emergent property of the flock of birds then influences where the individual bird will turn. And you'll see this in flock of birds, you'll see this in school of fish, again in the ant colonies and what jobs they decide to play, all the way down to the slime mold. The individual amoeba in a slime mold will also have an emergent property of having an individual creature come together and act as a colony that benefits the individual creature, but it acts as a group. And each individual amoeba as a identical DNA will take on different roles in that colony and create an emergent property that then downregulates back into the colony itself, helping the individuals decide what they're going to do. Is that an accurate representation, Doc?
Sure. It's exhausting, but yes.
I think you can sum it up to the elegant relationship between the mutable and unmutable.
Ooh, that's nice.
Uh-oh.
Flappy noodles are wiggling.
Yeah. But this is to some extent, this is where the wonder comes in.
Right.
You know, why is it that when you look up and you see a murmuration of starlings, it's breathtaking?
Yeah.
And that's one of the things that Jane, this artist I was working with, was very interested. You can have this sense of awe for the large scale, but she was also interested in talking to me about the cellular stuff, about having the same kind of response to the microscopic. So let's return to that, because that's where things, I think, where we get to. So far, we're simply like, okay, this is how things organize, big deal. What does that have to do with consciousness?
Right.
So the next step was, are cells a fundamental thing, the way I thought bodies were a fundamental thing? If you're looking at the school of fish, the fish is the fundamental unit. But the fish itself, its fundamental unit is cells. The fundamental unit of the cell is molecules floating in water.
Mm-hmm.
And the reason I wanted to mention the randomness thing is it turns out that the way, you know, we typically talk about how molecules interact as being driven by, we talk about them as molecular machines.
Mm-hmm.
So again, wrong metaphor. And where that metaphor takes us, if you think about, for example, actin and myosin filaments in muscle cells, the actin filament, oh, my finger came up. The actin filament is a straight line, and the myosin filament has an elbow bend, and it can move. And when you bind ATP, an energy molecule that derives from stuff you ate, that provides the energy for the myosin filament to move, to walk across the actin filament, and all the filaments move past each other and the muscle contracts. That's how all our muscles move. And that's been the dominant model. But this guy named Toshio Yanagita in Japan started looking at individual pairs of molecules. All this was based on looking at tens of thousands of molecules moving, and you could get the thermodynamic averages, and this all made sense. But when you look at them as individual pairs, you have an actin filament, and then you put it in a water solution, and a myosin filament, and he tagged that with a fluorescent tag, so you could watch it live in the microscope. And so what you would expect by the standard model is that they would just sit there, and then you would add ATP, the energy molecule, and it would start to move. But that's not what happened. And so back up, one of the technical terms for this low-level randomness is quenched disorder, which I think is just great, because you'll see why in a moment. When he did this, he put this in, and then he put the myosin molecule in, and they bound, and then all of a sudden the myosin molecule starts bouncing all over the place, totally randomly. Einstein described Brownian motion. It's one of his fundamental papers, that the molecules of the water are pounding on that larger protein, the myosin, bouncing it around in random movement. If you put dust on the surface of water in a glass, you'll see it moving. That's the same thing. So it turns out the movement is already there before you add the ATP. And when you add the ATP, suddenly that supplies the energy to quench the disorder into directional movement. So the energy that we get from eating isn't what drives our bodies. It's the kinetic energy of the water in which the molecules of your body are suspended.
That's crazy.
Right. And kinetic energy of water, that tells you what temperature it is.
Right.
That's why your body temperature is so important. Too cold, you have too little randomness in the system. You can't self-organize and you die. Too much, there's too much disorder in the system. You can't self-organize and you die. That's why body temperature is so important.
That's amazing.
That's really cool. Yeah.
Yeah,
okay.
That's really cool.
So now are molecules the fundamental thing? Well, they're just atoms that are self-organizing. So are atoms the fundamental thing? Well,
Right.
They're just subatomic particles that are self-organizing. Well, are those the fundamental thing? Well, they're just smaller subatomic particles.
They both are and aren't.
Right.
Down the rabbit hole we go.
That's exactly it. And that both are and aren't will take a complete switch now, because I'm also a Zen Buddhist practitioner. When Buddhism talks about about emptiness of inherent existence, that's a classic Buddhist phrase. What they mean is that whether something appears to be a reifiable thing that exists independent of anything else versus something that doesn't exist independent and in fact isn't a thing at all, this is exactly what they mean. But the Buddha and practitioners of meditation from diverse traditions who perceive this emptiness, they're not thinking of it like we're talking about now as an intellectual construct. They are experiencing that fact. And that if you shift your focus, it's a thing, but it's not a thing.
Right.
So a typical example I use of this, you know that classic image of two faces looking at each other, and the
Yes.
space between them looks like a vase.
Yes.
Is it two faces or is it a vase?
Yes.
Right,
No.
right. It's both, but you can't see both at the same time.
Yeah,
If
your
you
anterior
focus on-
cingulate cortex makes you switch, right?
Right, and people have studied this with fMRI. The best you can do is move very quickly back and forth between them.
Right.
But you can't see both. So if you see the vase, you know the faces are there, but you can't see them. If you see the faces, you know the vase is there, but you can't see them. And a complete description of the image requires both.
Right.
So a collaborator of mine in the consciousness stuff, Minas Kafatos, I get to hang out with a quantum physicist and cosmologist, which is kind of awesome for a
That's dope.
14-year-old nerdy boy still trapped in a liver pathologist body.
Very good company.
Yeah. So we talk about this as complementarity, like the quantum complementarity of light being both waves and particles.
Right.
It is both, but the experiment, the way you look, your perspective determines which one you'll see.
Right.
But both are the same. So now we're down into the quantum realm. And how about those tiniest things, quarks and such? Are they the smallest things? Well, physicists don't agree on what those smallest things are. Hold on. Not the hospital calling. Okay. I'm sometimes there's a liver that needs to be looked at.
Yo.
Yeah.
Says the seal
transplants.
holding an alcoholic drink.
Right. That gets me onto a whole other story with the New York Times. Never mind. So what physicists agree on, maybe they don't agree on what the smallest things are. One of the leading theories is strings, and that's what string theory is about. But there are other theories. But what there's general agreement about is that those smallest things don't break down into smaller and smaller and smaller things. They merely arise out of the field of energy that is the vacuum of existence. So we think of vacuums classically as being empty. But what we know from quantum physics is that vacuums are in fact filled with energy. And because of relativity, E equals mc squared, energy periodically turns into mass. And so the energy of the quantum vacuum starts popping off these tiniest things, whether they're strings or other things.
Mm-hmm.
And usually in matter-antimatter pairings, so they immediately self-annihilate and go back into energy. And that's the quantum foam, this coming and going of the smallest mass objects out of the quantum vacuum.
Right.
But some of them don't self-annihilate, and when they don't, they can then interact with other things. And when they start to interact, because there's quench disorder in the system, there are enough of them to do stuff, they start self-organizing into larger scale structures that are subatomic particles, which self-organize into atoms, which self-organize into molecules, which self-organize into planets and bodies and galaxies and the whole universe. So the entire thing, there is no place in this where a thing is a thing that's fundamental. Everything is process. And where you see things, it's because you're selecting a point of view.
Right.
But you always have to know, like when you're looking at the vase, there are those two faces. When you're looking at a human body, there's also this community, this flock of cells, and there's no body there at all. And the same when you're looking at a body and we're sitting on a planet, where's your boundary? So if you know, at this level of scale, your boundary is your skin, right?
Right.
And I see you two guys sitting there on your couch, and you see me, and we're separate. We're bounded objects. At the cellular level, well, where is your boundary? You're leaving cells all over the place. You know, this is the microbiome thing. When you shake hands with someone, you're exchanging your microbiomes.
The spice.
Spice nice. I like that. So when you have people living in a community, like, you know, New York City apartment with my husband and I, and if we had pets, we would all share a single microbiome.
Right.
Would there be us and our pets as individuals? Well, at the cellular level, we are actually one larger super individual.
Right.
With our boundaries being the cells. And the dust in your room is nothing but cells you've shed from your skin. So where is your boundary at the cellular level? It's at least as large as your home. And anyone you've hugged or kissed or, you know, shaken hands with through the course of your day. So at the molecular level, where's your boundary? Carbon dioxide, you breathe out, the plants breathe it in. They breathe out oxygen, you breathe it in. So at the molecular level, your boundary is the entire mass of life on the planet with which you're exchanging molecules all the time.
Right.
And I want two more steps. At the atomic level, where's your boundary? Well, at this level of scale, we are creatures living on top of this rock called planet Earth. On the other hand, at the atomic level, there's no atom in our bodies that we didn't drink, eat, or breathe from the planet, right?
Right.
So that means we are actually Earth that has self-organized its atoms into things that mistakenly think they are separate. So
we are the universe.
Yeah.
Yeah. Well, no, that's the next level. Right now, we're just the solar system. So
We're ignorant star farts right now.
Yeah. Yes. So, but people listening to this conversation are not quite as ignorant. So when we sent Curiosity to Mars, you could tell that story as it took 50 years for really smart mathematicians and physicists and engineers at NASA to figure out how to send a robot to Mars to send back pictures.
Right.
But it is just as true. That's the vase. The two faces view is it took 3.5 billion years for Earth to figure out how to self-organize and be able to reach out and tap its neighbor Mars on the shoulder.
I love that.
And both things are true. Yeah.
Yeah.
I love that too. That's one of my favorites. Now down to the quantum realm. Well, in the quantum realm, where are your boundaries? There are no boundaries in the quantum realm. Non-locality. Every tiniest particle, its most distant extent is the fullness of the entire universe. So the universe, we often think about it as an empty box in which we exist, or a place. But in fact, the universe is the substance out of which we arise. We are, and we are the universe. We don't live in the universe. We are the universe, deriving from it as it differentiates into structures within itself.
Yeah, and that's such a beautiful extension of a simple question that could be asked. I mean, you know, we assume that we're conscious and that, you know, we have a conscious intent. And that when you start to break that down into its components, you ask the question, you basically get to the point where you say, how do dumb atoms come together to create our macro system of consciousness that becomes us? And really, is it a dumb atom at that point? Or is consciousness then fundamental, creating the reason for the quantum foam to create the self-organizing? Like, there needs to be a mechanism. Like, what is the mechanism that causes all the self-organization?
And we still haven't gotten there yet.
Right.
So some people will argue that the quantum vacuum is the ground of being out of which everything arises. And that's sort of where I got.
Right.
But in speaking to this collaborator I mentioned, Minas Kafatos, the physicist, who's also, so I'm a Zen Buddhist, and I know academically some Jewish mysticism, and I've had a bit of a shamanic initiation, and so my brain is also in those realms. He happens to be a Kashmiri Shaivist with decades-long meditation practice. And if you just rest with Western philosophy, and everything we've said is completely in keeping with Western philosophy, with the exception of Descartes and the logical positivists of the Vienna Circle, that's worth a podcast. But
Right.
I'll leave
I agree.
that for now. And then complexity theory, relativity, and quantum mechanics. You put that all together and you get to where we've gotten.
Right.
But that leaves out the questions of people's direct experiences, either through meditation practice or through devotional practice or through using molecules like psilocybin or LSD, et cetera, et cetera. All of these produce vivid experiences of there being something even further below this, the non-dual realm, in which differences between things disappear. You can't apply descriptions. And what all these different cultures of practice describe is sort of in different terminology, because it's coming from different cultures, but kind of basically pure awareness.
Right.
No subject-object split. That's what we mean by non-dual. There isn't a me and an other, one observing the other. Science depends on that. At this level, though, beneath the quantum vacuum, that disappears into no subject-object split. It's the realm of non-dual pure awareness, awareness of awareness. And people can reach this through these different practices. I wouldn't be surprised if you guys have had a taste of it.
Double taste.
Yeah. So if that's pure awareness, how does all this happen? The Kashmiri Shaivists dive down in their meditation practices and philosophy in great detail to describe how non-dual pure awareness begins to separate itself into subject and object. But it isn't just a snap like that. It's a graded process. And as that happens, as you develop that subject-object split, that implies distance, both in space and in time.
Right.
And so as duality, subject-object, evolves from non-dual awareness, you get space and time. When you have space and time, you have space-time, the energetic quantum vacuum. And then you have stuff erupting from it. And then you have the entire universe springing into existence. So
wow.
That's what Minas and I have been writing about, and a bunch of other people, particularly if you look at Bernardo Kastrup, K-A-S-T-R-U-P.
Right.
You should talk to him. You'd have a really good time with him.
Okay.
We can hook that up. He's a philosopher who writes about this really brilliantly from a Western philosophy point of view.
I'm in.
Yeah.
That's awesome.
Send it.
Yeah. So that's sort of where I'm thinking about things now, that everything is in fact just pure awareness. And in awareness coming to know itself, the universe comes into existence.
Yeah, I tried to explain the concept of that and parallel with it how our human minds work on the delineation and the lines of demarcation of the layers of consciousness that we have that only get a certain amount of information, because that's a maximum level of information or an optimal level of information that a certain level of your consciousness can handle. But we all know, because of split brain patients who have multiple answers to the same question when they're asked, what do you want to be when you grow up? And the right hand is writing race car driver and the left hand is writing doctor simultaneously, because there are two layers of consciousness in your mind at a minimum. We know probably there are dozens of layers, because you laugh at your own jokes. Well, there has to be a person in there telling the joke, and there has to be a person in there who hasn't heard the joke who's then laughing.
You eat the extra piece of cake.
Right.
The one who doesn't want to look good in a bathing suit.
Exactly. And so I kind of equate that as, that's the same model that the universe uses to create a line of demarcation of awareness. where there is a separation between the layers of awareness that can then look at each other and interact with each other, but it's also part of the same one system.
Right. And again, two faces of the vase.
Right.
It is one uniform, non-dual, no divisions, no separations field of awareness. And at the same time, it's all these amazingly different things that are real things in and of themselves that that comprise the universe. And people fall into error. That sounds Western dogmatic religion. I won't pick one.
Very judgmental.
You fall into error when you reify one or the other as being the correct solution.
Right.
Neither is correct.
Right. They both just are.
How could you possibly use a binary form of assessment for something as complex as consciousness as in either correct or incorrect? That's asinine.
Yeah.
But at the same time, so, I had an interesting experience with my mom as she declined. She lost her short-term memory. So she was a little bit like a stoner. She couldn't remember 5 minutes ago. And what were we talking about? And so
your mom's memory.
Yeah. But she and food was really interesting. But she was in this perpetual bliss state. And I asked her, and when I was growing up, she was a pretty neurotic, anxiety-ridden woman. And I said to her, Maud, you even smile when you're sleeping now. How do you stay so happy? And she said, well, I don't really worry about the future anymore. And I can't remember the past. So all I have is the now. And when you live in the now, you're happy. And I'm like, wow, I hope for that kind of dementia. But, but the thing was,
imagine a Jewish mother actually being happy. Oh my God.
Well, that was my mother. I'm writing a book about it. That's a whole other thing. But meanwhile, we had to have 24-hour home care for her. She was suspended in this profound bliss state in which she was having visits from dead people. She was having spirit guides from the universe appear to her. And she was perpetually blissful, not just mildly entertained. She was in this bliss state, but she couldn't feed herself. You can't live in the realm of the non-dual. You'll cease to function as a living being.
Right.
So it's
slight hitch there.
Right. But if you insist that this world of differentiation in which we feed ourselves, we have sex, we eat, we have our jobs, we have our games. If you only do that, well, what have you got?
Right. You're
missing the other part that gives all of this meaning and context.
That's amazing. And see, that's why I love the model and the reverse cascade that explains absolutely everything, because as you raise every level, you work from the quantum foam on up with this self-organization up through solar systems and galaxies and galaxy clusters and superclusters and ultimately the universe itself.
The whole catastrophe, as one of my Zen teachers said.
Oh, right, yeah. And you get to the point where you're like, the whole thing is one, but that's exactly the same existence down at the quantum foam, where the whole thing, the non-local field, and we know that, quantum mechanics is a non-local phenomena where it does not have a limit to its expanse and has to be everywhere the universe is, lest the universe not exist, because the quantum foam is the reason that the entire Newtonian classical model can become the classical model. Is you've got the small bits of the smallest bits being created. That is not a divisible thing. There's one thing, and then that becomes the one thing of the universe. And to try to delineate that we are individuals anywhere inside that model, where it starts at one and emergent properties then downregulate all the way up through every portion of the existence to where we get to everything is one again. I mean, that's a tough nut to crack when you're trying to say, I deserve this lane more than you do.
Right.
Or I deserve more money than you do, or my politics is more important than yours, or my political belief or my religion is better than yours, I mean, that's a really slippery slope.
Yeah. It means we've forgotten the other part.
Yeah.
Right.
Well said.
Yeah.
Yeah.
All right. So what is this organ that you seem to have discovered that's kind of not an organ, but acts as an organ and is this brand new thing that has gotten a lot of the headlines lately?
Basically, colleagues of mine, this sort of came in from left field, colleagues of mine who are endoscopists, so the guys who put down tubes down your throat and up your butt to look at your colon or your stomach or whatever,
Right.
they had a new version of that machine that allowed them to look at the microscopic level at living tissue. And when they saw in most organs that they were looking at, the esophagus, the stomach, the colon, what they saw mimicked what we saw under the microscope. But when they looked in the bile duct, so back to the liver again, everything for me comes to the liver. The bile duct is so thin that they were able to see deeper into the wall. And the middle layer of all the visceral organs is connective tissue that holds it together.
Right.
And they were able to see into that. And when we see connective tissue on the microscope slide, it looks like layers of collagen stacked as a wall.
Mm-hmm.
But when they looked in the living tissue, it looked like open spaces that were filled with fluid.
Mm.
And long story short, what we realized is that whenever we take tissue to make a slide out of it, we dehydrate it and those spaces collapse.
Oh,
So
wow.
what is an open space looks like a wall.
Right.
On the slide, there are often cracks between those collagen bundles, and we sort of thought those are artifacts because dense collagen is so stiff that it cracks when you make a thin slide out of it. But it turns out those aren't artifacts, those are remnants of the collapsed spaces. So what we thought was real, a wall of connective tissue, was an artifact of dehydration. What we thought were artifacts, the cracks, were actually the remnants of the real.
Wow.
So the bile duct, who really cares about the bile duct? Me and about 24 other people on the planet, right?
And the bile duct.
And now bile duct, yeah, well, I guess it's conscious, so whatever. But it turns out that when you look at dense connective tissue anywhere in the body, there are always those cracks. Now I realize, oh, those are artifacts too. And so what different other cultures of scientific practice and healing have already recognized for decades, if not centuries. The fascia scientists have been talking about fascia this way, the osteopaths, cranial sacral workers, people in Rolfing, that connective tissue is fluid. They were right. Where we're coming in with what's new, but we didn't know that existed because they're not sort of allowed to publish in Western allopathic medical literature, which is where we were searching for other people who have seen similar things, and there were none. So we thought this was novel. What we're bringing in that's novel is that includes all the visceral organs and the entire dermis of the entire body. So we've made the picture more complete. So now we called it interstitium because we were injecting a fluorescent dye, which allows you to see the fluid moving through the spaces. So we were focused on the spaces. Interstitial spaces have been described in the body for a century, but these are larger interstitial spaces than had been described. So that's what's new from that perspective.
Mm-hmm.
They've been talking about it as fascia because they've been focused on the connective tissue, the collagen bundles that support the structures.
Right.
And again, face or vase. Is it interstitium or is it fascia?
Right.
Neither word captures the entire thing. So when we publish this, the first thing is the size of this is probably 20% of the fluid volume of the body is this space. It's lined by a novel cell type, or actually range of cell types. And it has very specific functions, which we're starting to delineate, some of which had already been discussed more generally in the fascia world and the osteopathic community, in Chinese medicine and Tibetan medicine. But now we're starting to do that with the Western scientific kind of rigor. And so that's rolling out. And so whether it's an organ or not, that was sort of the thing that was in the press release that suddenly exploded, mainly because there was no other scientific news that week. Stephen Hawking had died 2 weeks before, so if he had waited 2 weeks, we would never have been done.
What? So a couple questions.
A lot to be said for timing.
What is the definition of an organ?
Well, that's the thing. Who makes such a definition? There are different definitions. One definition is that an organ is a tissue that wherever you look in it, it looks the same. And so the liver, wherever you look, and doesn't look like something else. So wherever you look in the liver, it looks like liver. Wherever you look in the lung, it looks like lung. And lung never looks like liver, and liver never looks like lung.
If you're lucky.
Yeah, exactly.
Like your epidermis is an organ.
Yes, that's a whole other story.
Yeah.
I got samples. But,
how do they taste?
Yeah. Yeah, we're not going down that one. Rabbit hole. Fava beans, I know. I used to offer the medical students $100 for anyone who could come up with a liver joke that I had not heard before. Never had to pay out. So the functionality of the, and then there's, organs serve specific functions. And a lot of people, for example, anatomists were like really pissed at us because they're like, what are you talking about this as being a functional organ? It's merely connective tissue.
Right.
Model of the body as a machine. The parts that connect the parts, like screws and glue, aren't important other than just to connect things.
Other than just keeping everything together.
Yeah.
Until you try to build a house with Elmer's fucking glue.
Damn IKEA.
But in biology, every little bit matters. And so it turns out this isn't just connective tissue. It's probably a signaling pathway for cells and molecules for the entire body, for inflammation. This is how cancer spreads. It may be a buffering system for inflammatory processes. This is where the work is. We're figuring this out.
Wow.
So whether it's an organ or not, I don't really care. Organs in the body don't walk around with a little name tag that says, I'm an organ.
Right.
Please label me this.
Yeah, please label me this.
For our turd brains.
But do I think it's an organ? Shh. Yeah, it's an organ. but that's just labels.
Yeah.
We're interested in figuring out where it is and what it is, and what it does.
All right. So as a teaser for next time, I know you got to go, Doc, but I thank you for spending your time with today. For the teaser for next time that we get together, we've got to talk about your comments at Science and Non-Duality that were connected with if the quantum foam ultimately creates our consciousness and our multiple layers of consciousness, and that is derived from regular Newtonian matter, then what are the implications of potential dark matter consciousness that doesn't normally interact with our Newtonian classical model, but which does and coexists? I
sat in
tell
on
you,
that session.
Oh yeah, that was amazing. That blew my mind.
I can't write about.
No, and that's one of the things that I had not heard before, because there are very few things that I hear that blow my mind. That was one of them. I was like, holy shit, how could I have missed that whole little tidbit that it becomes a Pandora's box of amazement?
Yeah, so the teaser for that is the whole non-material realm of the astral plane. If that exists, how do we fit it in with all this?
Yeah.
To be continued.
Oh my God.
We will reconcile.
I think I'm going to have to write this up not as a scientific paper or a philosophy paper, but as a novel.
Yeah, that would be amazing.
Yeah, so that's buzzing around in my brain for when I have some spare time in 20 years. Invite me back to talk about that. I would love.
Excellent. Well, hey, thank you very much for spending your time with us today. We'll let you go, but for people who want to find out more about your work, where do they go?
Google me. My website died. I don't have an official website. I've got tons of videos talking about this stuff, some of which are reasonable quality, on YouTube. Just my name, Neil Theise, Neiltheise. But just you Google me and hit video, and I talk a lot, as you can tell.
Yeah, well, I enjoy it. I love listening to you, and so I really appreciate you spending the time with us today. Have a great remainder of your day, guys. You got anything?
Yeah.
How much time you got?
All right, well, we'll pick it up next time.
I'll let you guys talk. How's that?
Yeah, we will reconcile quantum mechanics and Newtonian physics next time.
Okay.
Got a couple
We got some theories.
got a couple tricks up my sleeve you guys might enjoy. I think I can weigh in on a few of these things.
Have a great remainder of your day. You guys don't forget to subscribe, hit that bell icon to get more awesome content like that. We love you guys. Talk to you soon. Peace.